Hello, this is Sprint 5 for Thrifty. Thrift shopping has become a major phenomenon, but there aren't any apps that make online shopping feel like a true thrifting experience. Each of the online shopping experiences are falling short. Why Thrifty? Thrifty is a social media app that connects buyers to sellers on campus and facilitates in-person exchanges. Along with combining everything from the previous sprints, we also need to follow the last sprint's learning prototype plan to answer these three questions. How can we cater to all buyer types on the Explore page? How do we build a trustworthy shopping experience? And how do we leverage our product to earn revenue?
Jane is a graduating college student who wants to sell her kitchenware quickly so she can pack lightly for her post-grad move. She likes to sell on Thrifty since Thrifty can quickly generate the tags for her listing, so all she has to do is create her listing and add a price, name, and condition. Since boosting her listing is only $1, she decides to try it to improve her chances of selling her items quickly. She enters her email and credit card information. She's able to pay and get her listing boosted for $1. Jane is also looking to enhance her wardrobe. She browses through the Explore feed and she finds a listing that she had previously liked already. She decides to message the seller to see if she would accept a lower price than listed. After all, it's a resale app, so you should be able to negotiate with the seller. Jane is very lucky. On the first offer, the seller accepts her offer of $20. The offering UI is super easy to send and update her offers. After they agree on a price, Jane coordinates her meetup with the seller to be at a safe and public location on campus. Thrifty is a great and convenient way to shop.
For our user testing, we interviewed 10 people in person. Since the results from our A/B testing in Sprint 4 didn't reveal a clear best choice for the Explore feed, we also decided to perform another iteration of A/B testing. We collected both quantitative and qualitative feedback through post-hoc event tracking and a Google form. The feedback we received motivated the changes in our design. On the mix feed, for example, users were confused about the difference between large and small pictures. Thus, we labeled bins with their title and added a gray overlay. Now users have a visual cue that clicking on a bin navigates to a different page. On the filtered feed, it was unclear that the bin name was a clickable button. Thus, we added a gray button area for the user to expand the bin. On both feeds, we also added a search feature so that users can search for specific listings.
Again, users found expanding a bin in the filter feed to be more difficult. However, viewing a listing and exploring their feed was slightly easier. The post-hoc data shows that it took users a longer time to complete their task on the Explore feed, and in-person testing confirmed this fact. Since bins are a core feature of our app, the team decided to use the mixed feed in the MVP. Overall, 70% of users found the buying process to be very straightforward and were able to make offers on items. 70% of users also found selling to be very easy. On average, it took about 2 minutes for a person to create a listing and boost their listing. Users liked the auto-generated tags and thought they were accurate. Testing on revenue streams revealed that 50% of people are neutral to ads appearing on their application. 30% of people are likely to stop using the app, while 20% of people would be unlikely to leave the app. On the other hand, only 40% of users stated they were likely to boost a listing. While boosting is a riskier approach, potentially losing 30% of users due to advertising is not ideal, especially since Thrifty has established competitors who utilize ads. Here's the updated business model canvas with boosted listings as a revenue stream.
This snippet of code is from our program that's currently running on Google Cloud. When creating a search feature, we didn't know an easy, time-effective way to search qualitative text data, but several users asked for the search feature in the previous sprint, so we had to make it work. We settled on a popular vector database called Pinecone. It uses vector embeddings, which are numeric struct that allows us to compare string text together. These two functions listed manage search and storage of the vector embeddings. We take the listing tags and combine them into a string and push them up into the vector database. And then when we search, we query for the k nearest neighbors in the database. This is a code snippet of our timing function that we use to track user activity on each page. These few lines of code pose a lot of challenges to our team as we fought with post-hog's interface. The biggest problem we had was being able to consistently track page timing information for unique users, which post-hog was unable to do. Even though it was crucial for automation for our user testing, our initial solution was to start a timer and end it when the page closed. Though our solution uses this premise, the naive approach did not work when we implemented React Native stacks. With the stacks, the pages render but stay on the screen. So we have to keep track of when the pages are being made visible or invisible. And this is what this code does using two separate use effects, one that starts a timer and one that starts a listener to see when the page goes invisible.